Okay, let's start with Arduino. In this section, let's focus on running our wake-word detection system on Arduino hardware. As of now, the only Arduino board that comes with a built-in microphone in the Arduino Nano 33 BLE Sense. This makes it is an ideal choice for TinyML projects because we don't need to add any extra hardware for the capturing audio. Here how it works step by step. Capturing audio. The Nano 33 BLE sensor has an onboard microphone that provides the audio input. If you are using a different Arduino board, you all need to attach an external microphones and implement your own audio provider.cc file to the handle the input. And the Arduino, it looks how we use the LED to indicate that words had been detected. You can see the Arduino Nano 33 BLE sensor board with the LED lights highlighted. Why this is useful? Having a built-in LED makes debugging easier because we can quickly see what the system recognizes speech. Later, this same logic can be extended to the other actions. Okay. Next, we will see about running the examples. For the deploying these examples, here what we all need: one Arduino Nano 33 BLE sensor board, one micro USB cable, and the Arduino IDE. In this project, books are available for to example code in the TensorFlow Lite Arduino library. If you have not already installed the library, open the Arduino IDE and select Manage Libraries from the tool menu. In the window that's appear, search for the installed and library named Arduino TensorFlow Lite. You can see that. You should be able to use the latest version. But if you run into issues, that version was tested with this book in 1.14 alpha. After you install the library, you can select the micro speech example which will show up in the files menu under the examples Arduino TensorFlow Lite. You can see in the picture. Here in the picture, there is the file. We are seeing the examples and they are selecting the Arduino TensorFlow Lite, and there is the different types: hello world, magic word, micro speech, and person detection. We will select the micro speech and we are click the micro speech to load the examples. It will be appear in a new window with a tab for each of the source files. And the first tab is micro speech. It's equivalent to the main functions.cc we are walked through earlier. In this tab we are seeing the board drop down list. If you are seeing if your device name does not appear in the list, you all need to install its support package. To do this, click boards manager. In the video appears, search for your device and install the latest version of the corresponding support package. Next, make sure the device port is selected in the port drop down list. Also in the tool menu, can you see there board Arduino Nano 33 BLE sensor and the board manager, it will be show it was connected or not. After the steps, finally in the Arduino window, click the upload button to compile it will be ready. After the ports are connected, finally in the Arduino window, click the upload button to compile and upload the code to your Arduino device. You can see there the figures The upload buttons are right facing arrow. After the upload as successful completed, you should see the LED on your Arduino board being to flash. After the successfully completed, it will be initializing in the serial monitor. Will be initialize was completed. To test the program, trying to say yes when it's detect the S, the LED will remain solidly for around 3 seconds. You can also see the results of inference Viva that around Arduino serial monitor. To do this, open the serial monitor from the tools menu. Now trying to say yes, no and other words. You should see something like to figure. In this picture, we are seeing the serial monitor displaying some matches. If we will say yes means it will be detect and takes time 3 seconds for the next command. If the Arduino serial monitor use can get the debug info. If the book shows the example says yes near the board and the LED showed light up the 3 seconds. Saying no means might not light the LED in the default example if only yes triggers it. But you could modify the code to maybe blink it differently for no. One important Arduino specific point, ensure the microphone is properly initialized and the library does not, but if you were doing from scratch, you call something like Arduino input initialize. Also, microphones sensitive can be an issue. Speaking clearly close to your voice and the board yield the best results. If you did not say anything or different voice means it will be show unknown. If you did not speak means it will be detect silence. Last one, we are seeing the warping up. Next we will see warping up. In Wake-Word detection is the key technology for voice enabled device. Enable hands-free interaction with the smart assessment, embedded system and IoT device using TinyML and TensorFlow Lite. We can implement efficient real-time speech recognition directly on microcontroller such as the Arduino Nano 33, BLE sensor, Spark Fun Edges and STM32. In this project, we combine Arduino audio processing, machine learning and even handling to build a low power always listening system. The system continuously monitor audio, recognize the wake word and triggers the prefind actions all in the real time. Future improvements cloud include multi-wake word detection, improved noise filtering and adaptive learning for better accuracy across different environmental conditions. For the embedded system, smarter and more interactive. Okay, from deployment we seen. Next video we will see about how wake word detection training a model.